Hello friends, these are the two problems which was asked in GATE 2019. So the first problem, we will see the solution. A concentrated load of 500 kilonewton is applied on an elastic half space. The ratio of the increase in vertical normal stress at depths of 2 meter and 4 meter along the point of loading. This is important, along the point of loading as per Boussinesq theory would be. So this is a 2019 GATE problem. Now you see the problem is that 500 kilonewton, that is Q equal to 500 kilonewton, is applied on an elastic half space. So this is the ground, which is considered as elastic half space, and this is the concentrated load Q. The magnitude of this is given to you as 500 kilonewton. The ratio of the increase in vertical stress. So you will have to find out the vertical normal stress at depths of 2 meter and 4 meter along the point of loading. So this is the axis of loading. So at 2 meter and at 4 meter, you need to find out the vertical stress by using Boussinesq theory. So Boussinesq theory is already known to you, that sigma v is given by 3 divided by 2 pi into q divided by z square for the radial distance from the vertical axis equal to 0. So here, because it is on the axis of loading, the r coordinate is going to be 0, and therefore at 2 meter, at z equal to 2 meter, sigma v1, we can calculate it. That is going to be 3 divided by 2 pi into 5 of q divided by z is 2, so 2 square. Then similarly at z equal to 4 meter, we can find out sigma v2 equal to 3 divided by 2 pi, point load remains same, q divided by 4 square. Therefore, as per given this problem, we will have to find out the ratio of the increase in vertical normal stress. So ratio will be sigma v1 upon sigma v2 will be equal to, now this 3 divided by 2 pi into q is going to be common, which will get cancelled. So what you are going to get it is 4 square divided by 2 square. That is 16 divided by 4 equal to 4. So this is the answer. So sigma v upon v1 upon v2, this is the ratio of increase in vertical normal stress of 2 meter and 4 meter on the axis of loading or along the axis of loading. So as per Boussinesq theory, the simpler way we can calculate it. So this is the part 1. This is the solution of question 1. And if we go to the next part, next question, question number 2, it is a rectangular footing. The size given to you is this rectangular footing is 2 meter by 4 meter, it should be. A 2 meter by 4 meter rectangular footing has to carry a UDL. So the uniformly distributed load of 120 kilonewton. So here the size of the footing, rectangular footing, is given to us. The width of the footing is 2 meter and the length of the footing is given to you as 4 meter. So if you have a rectangular footing, this footing is uniformly loaded. This is B equal to 2 meter and length L equal to 4 meter. And the UDLQ is given to us as 120 kilopascal. So as per 2:1, this is the top view. So as per approximate method or as per 2:1 dispersion method of a stress distribution, the increment in vertical stress at a depth of 2 meter below the footing is to be calculated. So this is the footing. This is the footing resting over the ground, and it is having a UDL which is given to you as Q equal to 120 kilopascal. Now the load is going to increase at 2 vertical and 1 horizontal, or 2:1. This is the dispersion of load. So 2:1 dispersion method of a stress distribution. We need to find out the magnitude or the increment in the vertical stress at a depth of 2 meter. So at Z equal to 2 meter, so this is Z equal to 2 meter. How will you find it out? It's quite simple. In theory, we have already seen that if this is the problem, then by 2:1 method, the sigma vertical will be equal to Q multiplied by the area of the footing. So area of the footing will be B into L. So this is the total load. So uniformly distributed load, Q of 120 kilopascal multiplied by area of the footing. So B into L. Now divided by, at 2 meter depth, this is going to be 1 meter and this is going to be 1 meter and this is going to be 2 meter. So 2 meter plus 1 meter plus 1 meter, it becomes 4 meter. So at 2 meter depth, B becomes 4 meter. So B plus delta B at 2 meter, what is the increase, and L plus delta L, what is the increase in this. So this becomes 120, B is going to be 2 meter, L is going to be 4 meter, and here the B is going to increase, B is 2 meter and delta B is going to be 1 meter here, 1 meter here. So this is 2 meters, so 2 plus 2 equal to 4, L is 4 meter plus, when you are going to at 2 meter depth, then 2:1, 1 meter and 1 meter, 2 meter in the length, the delta L will be 2 meter. So delta L is also going to be 2 meter. So delta L is going to be 2, delta B is going to be 2 meter. So this is the total increase in width, increase in length. Therefore, sigma V can be calculated as 120 into 2 into 4 divided by 4 into 6. So this 4 goes out, 2 3 ja 6. So 120 by 3 becomes 40 kilopascal. This is the answer. So this is the answer of this set civil engineering question of 2019 gate, set 2. This was set 1. So you can calculate this. The only correction is here. It is 2 meter by 4 meter, and the footing is rectangular, has to carry a UDL of 120 kilonewton, and the load dispersion as shown is 2:1, and then at 2 meter from the ground level. So at 2 meter depth of 2 meter below the footing, we can calculate that the increase, the total vertical stress is going to be 40 kilopascal. So this is the answer. Thank you very much. I think both the solutions have been quite clear to all of you. So that is the solution of this problem. Thank you.